I want you to think back to your 10th grade geometry class when they talked about points, lines, and planes. How many points does it take to determine a plane? 3. 3 as long as they are not on the same line. So it takes 3 points to determine a plane. Now, if you think about 3 space, there are a lot of planes in 3 space. There are a lot of planes. I'm thinking just in my head, you know, about if I have, let's say, a line like this, how many planes would pass through that line? An infinite number. I could have a plane coming in to the board at, say, a 90-degree angle. I could have one coming in and containing that line that might be at a 30-degree angle to the board. I have this line that I drew on the board that is in the plane that the board is in. So 3 points determine a plane, but what we're going to be looking for here would be something like this. Let me draw 3 points on my paper here, and I don't want them on the same line. We said it, but I didn't write it. 3 points to determine a plane, and let's add this in here. The 3 points are not on the same line. Collinear. Collinear might have 2 L's in it. I'm not sure. Does it? I'll put 1 for now. Okay. Anyway, 3 points, but as long as they're not collinear, that determines a particular plane. Now, what we're going to need for equations of planes is this. What we need to find the equation of a plane is actually 1 point on the plane and we need a vector, but a special kind of vector. And a vector that is orthogonal to the plane. And that would be enough information to find the equation of the plane. And if I draw a dot on my paper, I'm going to call that P sub 0, and it's X sub 0, Y sub 0, Z sub 0. So they'll give you a point on the plane, like they'll give you the numbers for the X component, the Y component, the Z component, and then you have to find a vector orthogonal to the plane. Or maybe they've given you that. So they'll give you this, and then we'll call it vector N, which has components A, B, C, where vector N is orthogonal to the plane. Now there's something kind of interesting about N. If N is orthogonal to the plane, then N is orthogonal to every vector in the plane. So you might want to think about that for just a minute. If vector N is orthogonal to the plane, then vector n is orthogonal to every vector in the plane. If the plane is my sheet of paper, then I'm going to draw this vector in fact, I'll draw several vectors here that might be in this plane. How many are there? An infinite number. There's a few of them. So my paper is my plane, and if I have a vector that is orthogonal to the plane, so it's going to hit the plane at a right angle. And that vector would form a right angle with every vector in the plane. So a vector orthogonal to the plane, it's going to be orthogonal with every vector in the plane. Well, what do you know about the dot product of two vectors that are orthogonal? It's 0. And there's your equation for the for a plane right there. That you'll find two vectors, and I did say we need a point, but what we do with the point is this. We'll say this: let P naught be x sub 0, y sub 0, z sub 0 be a point in the plane. So that's the one they gave you. Well, how many points are in the plane? Infinite number. So we'll say this: and let P, which is x, y, z, be another point in the plane. Now that one, they're not going to give you that one. That's going to be the point that's going to give you the variables in your equation of a plane. So that's another point in the plane. And then we have this. We also have n, which is orthogonal to the plane. Then we can find vector P naught P. We can find vector P sub 0 P, which would be x minus x sub 0, y minus y sub 0, z minus z sub 0, and this vector is in the plane, which is in the plane. So vector n, which is orthogonal to the plane, it is orthogonal to that vector. So vector n is orthogonal to vector P sub 0 P. I didn't put what n is, I put it earlier. The notation the book uses, I'll say, let's say n is vector ABC. So I end up with two vectors, and I know that their dot product is 0 because they're orthogonal. So n dotted with P naught P would be A times x minus x sub 0 plus b times y minus y sub 0 plus c times c minus z sub 0. And that equals 0 because the dot product of two perpendicular vectors is 0. There's the equation of the plane right there. I'll give it to you in the form that your book has it.